it's time. It's time. I'm waiting on this to close because I accidentally started building Unreal from it. Hour and a half. 9, 7, 9, 13. Yes. Okay. 9:13. That's an hour and a half. Let's go. I'm gonna go to bed on time today. I've been looking into Unreal Engine, trying to figure out replication, online stuff, and VoIP. I want voice in the game. I want to make it so you can cast spells with voice because Mage Arena is just too damn fun. It's a great idea. It's really, really good. But the main plugin that would make this work isn't updated for the version of Unreal now, but tomorrow I'm gonna do a little test with some Unreal stuff. Just gonna follow a basic little tutorial just to see if the shit this guy is doing is working. I want to be able to do it in C++. I want to start transitioning to be able to do stuff in C++. Like main systems like this, like VoIP. I think the abstractions of plugins and blueprints maybe aren't the most optimal, but I'll test it out and see if it's a usable thing. The point is to have a product that actually works and is fun. I want a single player RPG where I can use voice in a game and the game can listen to it. And one, we can make it multiplayer, but two, it can be single player and you use your voice to cast spells and shit. I just want to try that. I want to do stuff with my voice in the game. That would be sick. Alright. Yeah, this hair is looking like trash. We'll do that. It's better. Whatever. Had to update some investing stuff now because I got promoted, so I'm making $500 more a month. So now I'm investing a little bit more money. So nothing crazy, but more. Okay, C++. We were doing const expression classes, and last time we could just make const expression member functions. I thought, or data members, right? Just straight up const expression data members. See how far we got this. How far we go. Oh damn, I didn't save where I was. Oh wait, hold on. No, here we go. There it is, okay. So I can make a member function const expression, which in this case is not the constructor, it's just the member function that could evaluate at compile time. It doesn't even take any, and all it does is return which one is greater. Okay. Yeah, but what if the object isn't const and the data members aren't const either? Oh, you would have to make it a const expression. That would make sense. I was wondering. Alright, I need my fan. I'm just gonna have to keep bashing my head against Unreal until things start to click. Same thing with here, but... Oh, someone's playing loud bass in the car. I was wondering what was going on. And this is already implicit, but may as well make it explicit, right? This name is trash, but it's okay. Don't we need an if statement here? Oh. We just do ternary, huh? Oh, I guess we aren't doing this. We're making this a struct plane, which can be aggregate initialized. What is happening here? This doesn't have a name. But, well, that's not gonna help. Oh, it's because this isn't an aggregate. That'll do it. What was it saying earlier? Can't convert it. There's no instance of a constructor that matches it because these guys. This thing isn't an aggregate. Okay. What are you saying? Oh, big num. Okay. Cool. So we can make struct objects const expression because they are, well, they are aggregates. So we can at least make structs const expression because they're well, we can at least make aggregates const expression, including their data members. That's because const expression, it can evaluate it either. But when it's used in this context, and it's not passed any non-const expression stuff, and it doesn't do anything that requires runtime evaluation, it has to evaluate at compile time. All the criteria are satisfied. The body, the parameters, well, arguments, and whether, well, and the call context. Aggregates implicitly support const expression. Okay. Okay. But then we have const expression class objects, huh? We have a function in here. Function here. What did I say? A function in here? Alright, that's it. Let's do this one. Yep, now we have private data member, so this guy's not an aggregate. And we also have a user-defined constructor that takes two ints and uses a member list initializer to initialize the data members, which are private. And then we have a const expression function that returns them, returns the greater one. What does that even mean? It's not a literal type? What are you saying? Okay, I haven't seen that before. I was wondering. Like, can you only... I mean, it's just a non-aggregate, and it has. What's the issue here? Is it because it's const expression? Like the difference is here, it has private data members, non-aggregate. It has a public constructor with the default the normal syntax for member initializer list to initialize them with the constructor. A const expression function that returns the greater member. And then we create a const expression object. P needs to be a specific type. Oh, a literal type, meaning a type that's... Gotcha. I'm guessing that there is a limited amount of data types that can be made const expressions, and they're called literal types, something like that. Yep, and a constructor. Yep. It might be possible to create an object, all meaning like compile time. An object can't be const expression unless it's a literal type. Okay. A literal and literal type are related. Literal is a const expression value in the source code, and a literal type is a type that can be used as the type of a const expression value, meaning that we have all these values that could be const expressions. A literal type is that type of value. So we could have a literal standard string value, but a standard string can't be const expression. At least I think before C++ 20, maybe, or maybe even more recently. Gotcha. So we could have a yeah, like I could have a literal, and the literal could be of that type, but the type doesn't necessarily mean it's a literal, because if we have int x, x is of a literal type, but x is not a literal. If a literal always has a literal type, doesn't that mean that standard string could be? Maybe not. Most aggregates. So maybe const expression string is a thing, but I feel like it's not. Class for the const expression constructor. If the constructor is in const expression, it can't be evaluated at compile time. Okay. Pair objects can't be const expression because the constructor isn't evaluated at compile time. Which we could make const expression apparently. Like what could we have? We could have No. I guess the point for plugins is that in other people's code is that I need to understand how it integrates with the current code so that I can fix it if it breaks and I know what's there, but I didn't have to come up with it. And if it works, then awesome. I'm just worried about using other people's plugins in Unreal because I didn't make them. I don't know what's going on deeper down, and I feel like eventually that might fuck me up, especially if I have to go into the C++ and learn it later. I feel like I may as well know it from scratch, but that's probably not the case. I just need to become fluent enough to where I can look at a plugin and be like, all right, that's what's going on. I just have to look in there. And I can. All right, public, we need the constructor, members, no, it didn't have a data type or return type. Default copy constructor, okay. Which we could also do by making one. Oh, and the 4 issues are probably here and then further. Because without these, it thinks it's coming forever. Yeah, it makes sense. Cool. Implicitly defined constructors are const expression if they can be defined to be that. Okay, makes sense. Meaning that an explicit, or well, if it's an explicit default one, we would have to make it const expression. Yeah, so like we'd have to make it be. Boom. What were those errors just now? I'm curious. Oh, well, yeah, but it doesn't have, oh, it doesn't have, these constructors don't exist yet. Oh, well, I mean, we could make it. All the issues are in 2021. Okay. Just a lot of errors until your constructor is fully done and written. Const expression is part of the interface of the class. Well, it makes sense because if they're calling it in a constant context and it can't be created, then we're going to get errors. Okay. Oh, needed a little rest for a sec. Const expression members may be needed with non-const expression non-const objects. What does that even mean? We need to make some members const expression even for not making them non-const expression? Is it because we're using it in a const? I'm not sure. Is it because sometimes we need to pass them as const expressions, so they need to be const expression? Something like that? Oh. So here we go. So in main, we're saying, hey, we have a const expression variable. It's an int g, and it's initialized with init, and init returns the greater from a function. So init initialize creates a pair p named known where, and then we get the greater. Returns the larger value, and it's called in a compile time context because it's not passed any arguments. It's called in a constant expression context, and it doesn't do anything that's runtime only. It's arguments, body, and call context. I'll have to hang out with AI and figure out how to do this Unreal C++ stuff. Maybe. I just do it in the game, I guess. Just figure it out. I don't want to fuck my sleep up though. I was gonna drink a Red Bull for a second, but I'll go to bed in 3 hours. Not even probably. I'm probably gonna go to sleep at 10:30. I think I gotta catch up on my sleep. I stayed up a little bit, looking at Unreal stuff, setting it up really. The problem here is the grader. What must be dealing with values that are meaning that what pair P needs to be made. Well, I guess you could just make the const expression or the pair constructor const expression. We could also make the pair itself const expression, which is missing right here. In this case, all calls in here. So when we create P, we're calling a constructor, and that constructor must be evaluatable at compile time, which means it needs to be const-eval or const expression, meaning that P can still evaluate at compile time because we're calling a const expression function. But so much greater. If they weren't, we would get an issue. Okay. So I need some crazy music. An absolute bopper. Wait, this is kind of a bopper. Nah. No. Yeah. Giga Chad, holy. Oh, fuck this girl. So annoying. Alright, let's go. I didn't play anything, right? Alright, good. What do we want? Excuse me, I want a mouse. What really? I want a const expression int x. I want that to work. Right now it doesn't work because we don't know any of the shit. Doesn't have any of this, and it's not returning a const. Nothing. Can't do it. Alright, well now we can. Here we go. These need to be data members, so my naming convention is shit. Who the fuck is talking? Bro, who is talking? What's the issue here? $122? Oh, oops. Nope. Okay. Makes sense. We have a const expression. Hold. Yeah. I have a class object being created at compile time, or being created at compile time context, calling a member function of a class. Well, that means one, the member function needs to evaluate at compile time, but two, the object that we are creating must also evaluate at compile time. Which probably means the object needed to be created at compile time too. So, the constructor probably needs to be const expression. And because the constructor is already const expression, then that thing can still be created at compile time, even though we don't put const expression before. It seems like it's a clarity kind of thing. Like for type deduction for a pointer, we may as well make it an auto const, or a const auto, I think, just to know, hey, by the way, this is a const pointer. Well, it would drop top level, but const, and then, oh, there it is. So it would be const and then auto pointer to show that, hey, this is a pointer to a const. Even though we don't actually need that const in the beginning, because auto only drops the top level const, not the low level const. Well, yeah, it makes sense. If we're calling this function that must be evaluated at compile time, only const expression functions can be called in here, which means the constructor must be const expression, and so must greater, and so must init. Const expression member function can be const or non-const, meaning that we don't have to say const expression const. Because functions return temporaries anyway, so the point of even having a const function, I'm not really sure. I get const expression for optimizing, and maybe const for optimizing a little, but it's not like I'm going to change the value anyway. Not enough. Enough. Okay. Still non-static. We still don't know about static here. What did we use? Did we use static? I thought we used static for a second, or explicit. Maybe not. Hold on. Did I forget? Fuck. We had the explicit keyword. Oh, the explicit keyword was disallowing calls to it with implicit conversions, meaning that we put explicit on the constructor so that when we create the object and we don't say and we just put like brace 3 comma space 5 brace 3 5. Okay, sure, maybe a gun has a current number of bullets and a maximum number of bullets, or number of rounds rather. Well, I can't just say yeah, if I have a function that takes a gun, I can't just pass it 3 5 as a list that would get created. No, sir, that's not enough. That's an implicit conversion. That's disallowed. We need an explicit creation of that object, which means that we have to say gun and then initialize a list. And the point is that const expression function member functions used to be implicitly const, but not anymore. I don't know why. Are we talking const function meaning const meaning that it's cool for an object? I'm not sure if they're talking about the const that comes between the signature and like test. Like, which way are we talking about? It's not C. Is it a const function like that? Const expression non-const member functions can change members, meaning that it can evaluate at compile time and change data members. I mean, it seems like that would make sense because it's not implicitly const. But if the implicit object, if I create an object and it's const, then I can't call a function in it that changes the variables. Like maybe what if we do and this here can't be const because this guy isn't modifiable. What hold? Oh, well, it's saying const, so it's treating everything in there as modifiable. Yeah. Cannot be modified because it's accessed through a const object. A const object. Interesting. Okay. But now, what if we do it? Oh, I can't even try it. What? So we can do x.getX. Oh, because this guy's const, I can't even look at functions that aren't const. Now we can see it. So in this case, it would have to be const to even see it. And if we try to manipulate it, then it's through that function that doesn't work, okay? As long as the implicit object is not const. Okay, makes sense, yeah. Well, yeah, because if we saw here, this guy is not const, then we can make this not be const, and then we could still do x.updatex, and we see that because this guy isn't const. But if we make this be a const test, x dot, oh, we don't say update x anymore, right? And here we could say we could totally update x that way, even if the function was const expression. Okay. We have a pair, 3 and 4, and we have pair.reset. And then we're printing some parts, and then we're getting 0, I guess, and then some other stuff. So we have a pair, bro, people speaking in English in the background of this stuff is extremely annoying. We have a const expression constructor and 3 other functions. One initializes the shit because it's the const expression constructor. And then we have a const get the greater, a const expression void, which resets these guys both to be 0. Really? Because y is assigned 0, which is then assigned to x too. I don't like that, honestly, but. Because what if I wanted to change. Maybe not, though. I don't know. If I wanted to change the value and do this for one and this for another, then I would have to put my on its own line and then do some changing. I don't know. I don't like that. And then we can return a constant reference. We can actually return a reference to x, which should be valid wherever the object is created. In 0, takes nothing, returns a const expression pair. Well, can evaluate at compile time or not, and returns a pair. So it creates a pair that's named, it's a null value, it's non-const, yep. And then we can call pair.reset, even though pair.reset, or even though reset, the member function of pair, is const expression, it's not const. It doesn't mean that we can't use it to change members here. And then we can do pair p1, so we create a non-const pair, and we can call reset to get 0, and then it prints 0. Sure, we could do pair 2, and we could actually initiate it, or initialize it with 0, which returns a pair that was initialized to 0 copied by value. But maybe there's compiler or constructor elision, so maybe not. And it's also 0, makes sense. Meaning that in one case, we don't have to call 0. We can just go here, and we can say, hey, you have an object that's non-const. We can change values of it with a const expression function because it's not const. You could do the same thing in another function, and then you could make a const expression pair 3, but then we call 0, and it's initialized with 0, so we create a non-const pair, which can be created at compile time because the function, or the constructor is const expression. And then pair reset is a const expression function, which can also evaluate at compile time. So it's fine. So we're changing values of a non-const object at compile time, which is interesting. And then using that to initialize a compile time object. That is interesting. But we can't then call reset. We can call reset on the non-const pair that's used to initialize a thing, but I can't call reset on that const expression pair that's been initialized because it is const. It's interesting. At compile time, we can create a non-const expression object using a function, because a function that creates it evaluates at compile time, and I can then change it in the const expression function, because nothing about a const expression function says that you can't, and then I can initialize a const expression variable with it. That is insane. A non-const member function can modify members of non-const objects. That makes sense because a const expression member function is not necessarily is not guaranteed to be const. It's not implicitly const. And then a const expression function, member function, just like other functions, can be called in either context. Makes sense. We're looking through the example. Okay. Yes, we created a non-const one, so we can call a non-const member function to modify it. Yes. And it doesn't matter. Hold. Yeah, that makes sense because we aren't doing anything. Nothing here is const. P2 is the same thing. We'll hold. It's the same thing, but it's in a function. Even though it's 0, it's invoked at runtime. Yeah. Well, it's invoked at runtime because it's not invoked at a compile time context. Well, the point is, it's not if it's not invoked in a compile time context, it's evaluated in a runtime context. So it could still evaluate at runtime, yeah. So in 0, we create a non-const p. Yep. Makes sense. Yes, this is true. P3 is the interesting one, yep. Call to 0 evaluates at compile time. Oh, hold. We actually, yeah, we get a compiler error, but not for the rest of the stuff. 0 is cool, but not reset on it. We can call 0, which calls reset on a non-const thing, which is used to initialize a const expression thing, but we can't call the reset on that const expression thing. That is interesting and cool and semantically weird. But, I mean, makes sense. Yep. Because it's const expression. Yes, exactly. I wish you said that earlier. Reset is operating on a non-const, but it still must be const expression. Because you can do shit on non-const stuff at compile time. Which means it needs to be compile time doable, but it doesn't have to be const. A const function, meaning a function that doesn't manipulate or doesn't mutate your data members. Const and const expression are separate. Makes sense. Well, yeah, we don't have to initialize something with, well, hold. Yeah, but doesn't it say must evaluate to a constant? Yeah, but we can still initialize it, right? It's just that. It's initialized with a constant expression, so we can do a constant expression at compile time, get a value that is not actually const, and maybe it's good to go. Interesting. Oh, meaning a const expression member that returns a pointer to const or a reference to const? Yeah, makes sense. Yep. Well, it's not that crazy. We're returning a member that we're not changing that is, well, and we can't change it, so it has to be const, a function, and it's a reference that's const, which means we can't change it, so we have to say const, and it's const expression to evaluate at compile time, so we can return it to somewhere that takes a const expression. Makes sense. No time for CCP, what? Chinese Communist Party. Yep. 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 There's a fucking gnat in here again. Great. I've been pretty good about the cursing, I think. Today. Not my neck, man. Please. Hold. Member function that returned a const pointer. Yeah, exactly. A pointer that can't be received that's also pointing to a const in a function that is const being returned in a function that's const expression. Const, constant, const expression. Const expression, constant. Well, this is a const expression function that returns a const pointer to a const int, and the function promises to not change it because it must promise not to change it because it's a const pointer. Duh. Or rather, because it's a pointer to const. No. No, because it's because of the const after the int pointer part. Because we can't change the pointer. Yeah, it's beautiful. I'll take it. I like that. That's not crazy. Oh my god, these reviews are getting shorter. Scary. Okay, no, they're not. Procedure programming procedures. Yep. Data objects to these, but we have to do them separately, and it's just ass. With object oriented, we can create, program defined types that link the behaviors and the properties together. An invariant is something that must be true in order for the object to be valid. The player's invariant must be that its position is within the bounds of the world, or must be alive, or must be in play, or something like that. Dude! It's a freaking gnat that just keeps touching my face. So annoying. I'm gonna bait him. I'm turning the light off, and he's gonna go on the screen. Because all bugs love light, surely. Bro. Please. Earbuds got pulled out. Yeah, it must be true for it to be valid. Makes sense. It's a violated class invariant, meaning like a fraction that has a numerator of 0, or a gun that has a current rounds of that's negative. A test score that's 0, a name without an ID, or an employee without an ID, etc. Probably more likely unexpected than undefined for the behavior of an invalid state class. Or class with an invalid state. Yep. Excuse me. Yeah, it's the pointer to this. Non-members are free. Makes sense. Yeah, if you don't have any fucking data members, what are you doing, bro? Just put the functions in a namespace. Const member function is a function that says, please, I promise I will not change the data members. I will not do it. Not the const data members. Or even if they aren't const, if it's const, it's just saying that it's not going to manipulate them. It's kind of like a reference where we can make it const even though the object that it's the referent is not const. So a const member function can only call other const member functions. Makes sense. Yeah, the access level, whether it's public, private, or protected, makes sense. Per class, meaning that we could have two separate objects, and one object could call another object's data member because it's the same class. Public members, no restrictions. Yep, they can be called by main, whoever. Yep. And of other classes. Well, and it can also be called by, yeah, that's fine. Yeah. Need more music. Isn't this one busting? Yes, it is. So am I. Okay, you didn't hear that. All right. Should we call code that exists outside the members of a given data type, a given class type? Oh, yes. Stuff that's outside the function. Public, yo! Except, well, yes, excluding other objects of the same class, because that's the same class, yo. Make sense? Structure aggregates. Aggregates must have all public members. And no constructor, allegedly. No user define, no program define one. Yep. That's the difference between struct and class. Makes sense. Yep. Yep. Access specifier, private, public, protected. Cool. Holy shit. Okay, never mind. This shit gets longer. Yeah, we use the getter set. Yeah. Yep. The interface of the class is this public stuff that we use to get and set and change the class without giving access to the actual underlying stuff underneath. For example, create an employee. We have an object that's the name. We have an object that's the first character of the name. Whenever we call the constructor, the public constructor, we create the object, we pass it the value, and what the constructor does is one, initialize the value, but it also initializes that invariant, that private data member, that first character, so that every time we create the object and every time we assign it, yeah, we could also have that in the setter too. Every time we call the setter also updates the character, the first character to be the first character, the dot front of the string of the name. Yep. Public interface. Okay. And the implementation is all the shit on the inside, all the private stuff, all the stuff that's actually going on, all the things that are called on the inside that other people can't call with the public implementation. Boom, the stuff that we can't access the private. Yes, and we hide the implementation via encapsulation. So encapsulation could be the data hiding part, but it could also just be the value of object-oriented programming, where I create a player to bundle the card hands, or the hands of cards, with the shuffling functions instead of having to keep those separate and totally unrelated, or not directly related, indirectly related. Yes, so there's implementation and then there's interface, the public and the private parts. Declare public. Prefer to declare your public stuff first. Oh, nah. Yeah, nah. No, I don't like that because I like the private, and then afterwards, I like defining stuff and then defining things that build upon it. Meaning that I need a private data member and then I need a getter. I don't have a getter and then a private data member. Nah, fuck that. I just don't like that. I like the pieces of my car in the front of the manual and then each piece separately. Oh, this is gonna go maximum mode. Oh yes, better quality too. Constructor, yes, lets us use list initialization. At least we can use brace initialization to create the objects, yeah. Create a non-aggregate class type, makes sense. And that's because there's a default constructor. So, I mean, we're always going to have a constructor, really. But we might find not that we don't have a constructor if we're trying to create it in a certain way. A member initializes the list, yes. Makes sense. Yeah, exactly. Other than the, yeah, because if we have a constructor elision, the compiler can say, hey, motherfucker, you're using a copy constructor when we don't need to, or you're using the normal constructor, the one that's not copying, the one that takes raw data and then creates it. These are not needed in this case. Let's make it as efficient as possible, and you might lose calls to the constructor. So if you had behavior that you wanted to happen each time you wanted to do the constructor, well, like maybe every time you generate a copy of an enemy or something, you want there to be like some fade particle effect or whatever. Every time you create a constructor, that way you can see it, well, you might be losing some of those calls because the compiler would mandatorily optimize them out with constructor elision. Right there at the bottom, it would be eliding them. All right. Default constructor, all default or none. Basically a constructor with no arguments, yes. Or no parameters, rather. Well, no, that you pass no arguments. So it's not no parameters, it's no arguments. Yep. Yeah, so that the fucking thing can be created. Hello? The implicit default constructor, yes. It's the one that we didn't even have to create. We could make one that's default and override it and add shit to it, and that's default. Or we could we could use the implicit one that's already there. Oh yeah, we could delegate initialization. And we call them hold. We call it in the member initializer list. So we say, hey, we have a constructor that takes 2 arguments. And when you call it like this, in the member initializer list, we're going to call the actual function that should be, or the actual constructor that should be doing the creation, the one with 3 parameters, because an employee needs a name, an age, and an ID. You only provided a name and an age. We need an ID. So what they do is we default the ID to 0, or whatever, 999, something like that. And then maybe it's a static variable that gets changed every time, something. So it then calls the correct constructor, the one that creates it with an ID to initialize the proper value, and we pass it the value it needs. For example, por ejemplo, what are you complaining about? Oh, it's because we haven't put anything in there. Okay, it's fine. And then we'll make another one real quick. Employee, const standard string reference name and age and ID. Oh, the gnat's coming around. He's back. And then here we could say boom! It says, hey, we have this default value of ID here. Maybe it's 999. And then whenever we do that, maybe like we call this guy, and actually it doesn't even evaluate this. We could test this here. He's 43 and has no ID. Let's do. Well, actually, we might even get copy elision here, but I'm gonna hopefully not. We'll find out. Oh, it did do both. So it... First, hold. I'm gonna move this over so we can see when this happens. So, where the fuck are we? All right, we're here. We're in this body, and we're saying, okay, call. Oh, so it does do both. So it delegates the construction part, but then comes back and runs the body anyway. So it says, hey, actually go in there and initialize all the pieces, initialize them name, initialize them age, initialize the ID with the default value, in this case 999, which we can see. We'll hold. Oh wait, fuck, I don't think that actually works. Maybe not. And then it comes back, and then it runs that body too. Interesting. Yeah. So the point there is if we have copy elision, it will remove this extra stuff. Let's just do, sure, a print. I mean, do we even want a print here? I mean, yeah, I'd rather, why not, right? Can't do const expression there. Could make this const expression. Right? No, because those are both doing runtime shit. Oh shit, the ID isn't actually there. So we could do... In this case, we actually may as well do const expression int default ID 999. And then this is just default ID, so that if it is, and then default ID, it's hold. What is happening? Wait. Oh, I guess not. Const is okay though? Okay. What about here? Okay. Hold. Oh, the point here is hold. Wait, yeah, but it should be... Yeah, but it should be calling this... No. Okay, don't know what happened. Okay, it still doesn't work. I think that's the syntax to construct it, actually. Like, if I change this to just be... I mean, it's not going to be using it now, so it might be upset. Yeah, it would. Fuck. So, like, it's fine there. I'm not sure why it's pissed at the default ID. What? Oh, oops, I didn't mean to put a semicolon there. Hold on. Same issue. All right, what's the issue here? Yeah, it's uninitialized. MID. And the point is that we would have to have this be, oh, that makes sense. So I could give it this default value, and then I could make it a default argument. I think that's what I would do. Okay, bro, chill. Wait, really? Still? Are you fucking me? Yeah, but MID isn't specified here, so I mean, even if we wait, what are you fucking bugging for? Why is it saying that? Line 40? What are you fucking saying? Bro, this is Visual Studio. Well, ID's unused here. Bro, what? But if I omit it, then we're gonna get an ambiguous call. There it is. Wait, what? What is it even doing? Yeah, see, it looks like that's because of an ambiguous call. I don't see the difference right here. Default ID is an integer. MID, if we call the default constructor, initializes MID with 999. When we call this, doesn't this need to be static? Isn't that a thing? It is. I don't know. I think it's because it somehow makes this. I think it's because of. I think static in this case, if I just pretend that it's the same as a local variable, well, no. Somehow static initializes this guy early enough so that. Because it's treating this, right now if I do this, it's treating these as all uninitialized, and this guy's just never used. And then when we call this guy hasn't been initialized because he's initialized in the constructor. And these values are only used, 0, 0, 0, are only used when this guy, or when we call the default constructor, or when they're omitted. But because we're using them here, somehow we have to make it static. All right, I'm not fully fluent on that, but we have to make it static. Okay. Constructors can delegate. Constructor chaining, they're called delegating constructors. Okay. Delegate or initialize. Not both. Yeah, exactly. So the first one is not used to initialize anything. Okay. Excuse me. Every object is an object. Yeah, we already know that. Topic constructor is the one that we pass, excuse me, a class object to. Or, well, the topic constructor is the constructor call when we are initializing a class object with another class object of the same class. Of the same type, I guess we could say. The class is a program-defined type. It'll create the implicit copy constructor, just like the implicit default constructor. as if says that, but it does not do that for copy elision. Or, well, oh, it is copy elision, not constructor elision, copy elision. So where it doesn't copy it, like it'll explicitly do it, but if you're copying it and then copying it, it undoes the copy. Because that's the expensive part. Like, default constructor or normal one, cool. We're creating an object and assigning it value based on what you put. But if we're doing copies, we're just making a copy of the same thing, which means it's probably not valuable. It's probably inefficient. Oh yeah, here we go. However it likes, yes, as long as they don't expect observable behavior. But in this case, it would. Dang, it didn't say that. It was supposed to say that make copy constructor or make constructors. I guess just leave the bodies empty when possible, so that they don't get alighted. Okay. Oh, a function is converting a value involving a program-defined type, a user-defined conversion. I mean, you may as well call it a program-defined conversion at that point, but. And right now, because a constructor takes values that aren't program-defined types, well, the point is, even if it's not, if it's from a program-defined type to another program-defined type, it's a converting constructor. Because a constructor is creating a program-defined type. It's creating an object out of one, or creating an object of one. And by default, unless we make them explicit. Yep, there it is. Make any constructor that accepts a single argument explicit by default, because I guess odds are that we want that argument. If implicit conversion, hold. If the implicit conversion between types is the same, the point is that implicit conversions probably could fuck things up. So make it explicit so that you don't get any. So that you create an AK-47 not with a character, but with an integer, and we don't accept it. For example, please. I could create a temporary like this, but I could also create one like this, and bam! Uh-oh. Uh-oh. So much for that, huh? Oh, here it is. That's the point. Because we're not doing an implicit conversion, we're doing, well, we're doing it explicit, something like that. What if we did And it takes a gun called X, whatever, and it doesn't even do anything. And it's unreferenced. Okay, fine. Those are fine. All right, and then here we'll just say and now we're gonna say test X, hold. Nope, still not good. We need to say gun X. And then if we do test Y, no. But if we say gun Y, then it's okay, because I guess it's treating a character as an int, so okay. Or it's just a conversion, that's okay. Oh, wait, hold on. Okay. An explicit one cannot be used to do copy or copy list or implicit. Interesting. Okay. Constructor that accepts a single argument explicit by default. We could say no. Okay. Do not make copy or move ones explicit. That's the point. If we make a copy constructor explicit, then it could happen, but it's useless. There's no point because it can't. It only accepts a reference to this guy, and we can't do conversions, I think, in references. Yeah, a reference must match the type of the thing it's referring to. Member functions can be const expression, but they are not implicitly const. Yep, exactly. There it is. Man. Okay. Nice. And it's probably because we don't need all these to be inside fractions. We could have these be elsewhere so we can multiply multiple things. So we could have it be with a template or something like that. All right. So a class named point2d. Double. Two doubles, both defaulted to 0. Okay. Oh. All right, I'll take my standard break. I'll be lenient. All right.